For 5 days, the question hung in the air. Earth was flying through a debris field of unknown origin. Hundreds of meteors, fireballs over 5 countries, and nobody could find the source. Tonight, we can. NASA has an answer, and it is so much worse than not knowing. Because what they found wasn't an asteroid, it was a system. A hidden conveyor belt running between the sun and the Earth, dropping rocks into our path on a schedule we didn't know existed. 282 meteors. One cluster, one terrible orbit, and one detail buried at the bottom of the paper that almost nobody is talking about. We'll get to that in a moment. First, you need to understand what just changed. 3 weeks ago, NASA Johnson Space Center released a study you weren't supposed to see in a panic. It was published quietly in the Astrophysical Journal on March 27, 2026. The lead author is a postdoctoral fellow named Patrick Shober. He's not famous, he's not loud. He spends his days looking at footage from automated sky cameras, thousands of them scattered across Canada, Japan, California, and Europe. They run all night, every night, watching for streaks of light most of us would call shooting stars. Shober calls them clues. And what those clues told him should have been the lead story on every network in America. Let's rewind to the meteors. Most meteor showers, the Perseids, the Lyrids, the Geminids, they all have parents, comets mostly. The comet swings around the sun, sheds dust, the dust spreads along its orbit, and every year when Earth crosses that orbit, we see fireworks. We've known the parents of the famous showers for over 100 years, but Shober was looking for something different. He was looking for a child without a parent. A meteor stream so new, so freshly formed, that nothing in our catalogs could explain it. He found it. 282 meteors, a tight cluster, a trajectory that didn't match any comet, any known asteroid, any catalog object. The new shower has a name now, M2026A1, and it shows up between March 16th and April 7th, every year. After April 10th, witnesses reported fireballs over Ohio, Turkey, Australia, Texas, and New York, all from the same direction, all on the same trajectory. So Shober did what scientists do. He ran the numbers backward, and the orbit he reconstructed is what should have made everyone in the room go silent. These rocks aren't coming from the asteroid belt. They're not coming from beyond Mars. They're coming from a region of space we almost never look at, because we physically can't. Their orbit takes them almost 5 times closer to the sun than Earth ever gets. They're skimming the corona. They're being baked alive every pass. And their composition, the way they fragment when they hit our atmosphere, tells Shober something specific. They're rocky, not icy. They're tough, tougher than comet debris, which means we're not dealing with a comet here. We're dealing with what scientists call a rock-comet. An asteroid behaving like a comet, shedding material, leaving a tail of dust, but made of solid stone instead of ice. The sun isn't melting it. The sun is cracking it open. Now here's the part that changes the story. Shober has the orbit. He has the meteors. He has the shower. What he does not have is the asteroid itself, the parent body, the thing that's actively shedding rocks into our path, year after year, right now, as you watch this. It is invisible to us. Why? 2 reasons. First, anything that orbits that close to the sun is constantly hidden in solar glare. Every time it would be visible from Earth, the sun is sitting right behind it. Telescopes can't see through their own sky. Second, it's dark, burnt, charred from millions of years of solar bombardment. Our optical surveys are tuned to catch reflected light. This thing reflects almost none. We have a parent we cannot photograph, dropping rocks into our neighborhood on a schedule, and we only know about it because of the dust trail. Let that sink in. For the past 2 decades, every single one of NASA's planetary defense missions, DART, the Asteroid Impact Test, NEO-Surveyor, the upcoming infrared telescope, they were all designed around one assumption. The threats are out there, beyond Mars, far enough that we have years to see them coming. We were watching the deep field. Shober just proved we should have been watching the inner system, right next to the sun, the one place our telescopes are physically blind. And he's not talking about hypotheticals. He's holding 282 receipts. Now connect this to what happened on March 8th of this year. A small object, somewhere between car-sized and washing machine-sized, exploded over 5 European countries with absolutely no warning. Fragments hit at least one house. Our entire planetary defense system, the most expensive sky monitoring infrastructure in human history, missed it completely. We didn't see it on day 5. We didn't see it on day 1. We saw it only in the moment it was already burning. Until Shober's paper, that was just bad luck. After Shober's paper, you have to ask the obvious question. How many of the recent fireballs over the United States, the ones in Texas, the ones over the Midwest, the ones lighting up dash cams from Ohio to New York, how many of those were small rocks from his hidden asteroid? How many were debris from the parent body we cannot see? He doesn't know. He says so plainly in the paper. It is possible, he writes, that what people saw came from this asteroid that fell victim to the sun. Possible. That's the kind of word a careful scientist uses when he means almost certainly. So what happens next? There is exactly one mission on the books that might find this thing. It's called NEO-Surveyor. It's a NASA infrared space telescope designed specifically to detect dark, sun-approaching asteroids that optical surveys cannot see. The infrared spectrum is the only band where these baked rock objects glow brighter than the surrounding sky. NEO-Surveyor was supposed to launch this year. It's now been pushed to 2027, maybe later. Until it gets up there, the inner solar system is, in the most literal sense, a blind spot. And here's the part the report doesn't quite spell out, but Shober clearly understands. If there's one rock-comet shedding material into our path, there are almost certainly more. The conditions that create them, a rocky asteroid wandering into a sun-grazing orbit, aren't unique, they're common. The reason we've never cataloged them is the same reason we never cataloged this one. We weren't looking in the right band, in the right place, at the right time. The pipeline isn't a one-off. The pipeline is a category, and as far as planetary defense goes, we just discovered we've been guarding the wrong door. So what does this mean for you, sitting wherever you're sitting right now? In the short term, nothing dramatic. The objects in this debris stream are mostly small, marble-sized, pebble-sized. They make pretty fireballs. They damage maybe one rooftop per decade. They're a curiosity, not a catastrophe. The big rocks, the city killers, the regional disasters, those still come from the outer system on timescales of centuries. The Carrington-class asteroid event, if it ever happens, will probably give us months of warning. Not minutes, but this is the lesson that should land hard. We have a $30 billion planetary defense apparatus, mass spectrometers, radar arrays, telescopes on 3 continents and in orbit. And it took one postdoctoral researcher looking at amateur meteor footage on a laptop to discover an entire family of objects in our cosmic neighborhood that had been invisible the entire time. If a guy with a laptop can find what NASA's billion-dollar telescopes missed, what else are we missing? That is the real headline, not the meteor shower, not the rock-comet, not the parent body we can't photograph. The headline is this: for the first time in modern history, we have direct mathematical evidence that there are objects right next to us that our entire defense system was never designed to see. 5 days ago, we said the source was unknown. Today, the source is known but invisible. I'm not sure which version of that sentence keeps me up at night more. So here is the question I genuinely want your honest answer to, and I want you to actually leave a comment on this one. If NASA announced tomorrow morning, confirmed on the record, no walking it back, that there are dark sun-grazing asteroids dropping fragments toward Earth on regular schedules and we cannot see them with current telescopes, does that change anything for you? Does it shift how you think about the night sky? Does it shift what you'd want our space agency to fund next? Does it shift what you'd want your representatives to push for? Or does the idea of an invisible threat in the inner system feel exactly the same as a visible one in the outer system? Distant, abstract, somebody else's problem? I'm not asking to be dramatic. I'm asking because Patrick Shober's paper is going to sit in the Astrophysical Journal and gather dust, and almost nobody outside of planetary defense circles is going to read it. The conversation about what we do next isn't going to happen in NASA conference rooms. It's going to happen, or not happen, in places like this comment section. So drop your honest answer, read each other's, disagree, argue, push back if you think I'm overselling this. I read every comment on this channel. The people who keep showing up here, remember what it was like when our generation believed space was something we conquered, not something we cowered from. I'd rather hear your real take than your polite one. The sun has been baking that asteroid for who knows how many millennia. We've been watching for 5 weeks. We have some catching up to do.